Yeah, hopefully it's recording now. So here's your moment of inertia. And what's the units for this one? You guys know?
Meters cubed. I mean, meters to the fourth.
To the fourth, exactly,
Yeah.
from solid mechanics. Okay. So I think we have everything now. We have the area. So let me highlight. So we have area. We can calculate the area of a semicircle. We have HCG, which is this one. And we have IXX now, and sine theta is 1. You can, what's the value if you plug in all the numbers, YCP?
It says 0.09349.
It's 0?
Yeah, 0.09349.
49. Okay, and it should be negative, right? Don't forget the negative sign. Yeah. Is that what you guys got to? Are you guys good? Just doing some calculations here. 9 pi over 2.
So would he give us that formula on the quiz?
What formula?
The one for IXX.
On the quiz?
Yeah.
You can't use your textbook on the quiz?
Well, then he lets us have this like, it's like a cheat sheet. You fill it up with like formulas, but I think he said that he was going to put some formulas on the quiz, like he was going to give them to us.
Mm-hmm. So who's your professor? Because I don't know, to be honest.
Armin Agigi.
Oh, yes, Professor Arma. Yes, I had him before. He does give you formulas, but if he doesn't, he's not gonna tell you you can't use the book to find formulas. There is no reason you should memorize IXX. No reason. So if he doesn't give you a formula sheet, I'm pretty sure you can look at the book and go to section 2.5 and find, because all these formulas I got from the book. I'm not gonna memorize these formulas. But this one, yeah, for sure, we're taking fluid mechanics. You need to know this. The basics you need to know. But IXX, no reason. It's just a constant.
Okay.
Right? Yeah. And then this is, what's this one we got? YCP. Negative 0.09. What's this distance?
Distance from the centroid to the center of pressure.
Pressure. So it is downward. You should go from the centroid exactly to the center of pressure by 0.09. And that's your force. And you're going to have P. You do equilibrium equations and you get the value for P, right? Sounds good?
Yes.
Okay. So what was I think, Nick, you asked about this problem?
Yeah.
Yeah, what was confusing about this problem so we can look closely at it?
The thing for me, it was the YCP, because like you needed a specific formula because it wasn't like a rectangle, and you couldn't find it based off of the triangular pressure distribution. So yeah, that's what I was wondering.
Oh, okay.
Yeah.
Yeah, so
because on the quiz, I was just wondering if like we needed that specific formula, like if we needed to actually memorize it or not.
Yeah, so I'm not sure. I know when I took Professor Seong, yes, we did memorize formulas. I'm not sure about IXX, but for these formulas, we did memorize. And once we jump to chapter 4 and 5, you'll see so many formulas. We did memorize them. But for IXX, I'm pretty sure he gave us IXX and he gave us YCP as this one. If you solve like so many practice problems, you'll memorize this
Just
one.
get an idea.
Yeah. So That's but I don't think, yeah, I don't think the quiz is not there just to test how you memorize formulas, just how you apply these formulas.
Okay.
Right, so hopefully you should be fine. If this was the only issue is just knowing for formulas,
Yeah,
I
it's
think
just that.
you should be fine, really.
So, well, my other question, so remember when you solved the curved gate,
Mhm.
and then you took the projection of the area, and it's, you know, it's like a rectangle when you're looking at it, and then you
Yes.
look at the pressure, and it's like a triangle. So the reason you did that was basically because that was more of like a uniform area versus this is kind of, you know, like it gets skinnier as you go up the gate because it's a circle.
Uh,
That's kind of the only reason you can do that is because it's pretty much uniform the whole way through.
I'm trying to
Do you get what I'm saying?
think about it. Yeah, do you have like a triangular pressure distribution on
Right.
this semicircle? And the answer should be yes. I think you should. But it's not gonna look a perfect triangle though. You're gonna have some
Yeah.
weird edge at the top. So I don't think it applies in this case.
Yeah, because in this case, like, it's not so easy just to find that.
It is not. Yes, it is not. That's why we went
Use the
straight to
formula.
the formula. I
Right.
wasn't even picturing how the pressure distribution looks like, because if it's a flat gate, yeah,
It's just a
just do
triangle.
just a normal triangle, very simple. For this one, yeah, I'm not so sure it's gonna look a perfect triangle. No, at the end, I think it's not gonna look a perfect triangle. So you can't use what I did in that problem.
Okay.
But remember this: the formula always works. This
Yeah.
one, this always works. So there is no guessing there. If you're doubting yourself, go straight to the formula. Don't even think about it.
Okay. Thanks.
Okay, great. Okay, any more questions, guys, from chapter 2?
Can we practice a buoyancy problem?
A buoyancy problem. Let me see. I have some notes here. We did we do the iron ball one submerged in
Yeah.
water? Okay,
Yeah, we did that one.
we did that one. Uh, yes. 2 days ago on Tuesday, I think Tenzin was here and he asked about this problem. I can share my screen and let you guys see this problem. It's actually a pretty nice one from the homework. So if we go, oh, can you guys see my screen?
Yeah.
Okay, so let me try to find it really quick. It was a block of steel, I remember. This one, 2.122. You have a block of steel right here, and it's submerged in both water and mercury. And we're asked to find this ratio, A and B, the ratio between A and B for the block. So basically the height.
Right.
This was from the homework, hopefully. Right? Are you guys good with this one? Did you try to solve it?
No, I didn't try to. We can do it.
If you guys want to, I was planning to do chapter 3 for today, but I mean, if you guys have quiz tomorrow on chapter 2, yeah, let's do as many problems as we can on chapter 2. You guys want to see this problem, or you have a better one?
This sounds like a good problem.
Yeah.
Okay.
This is a good one.
Okay, great. So let me stop sharing my screen and go to my iPad. Okay, let's go to the whiteboard and let me draw the problem. So this is problem 2.122. And you have water and mercury. So this is water. Of course, water is on top, right? Because it's less dense than mercury. And you have steel block right here. This is steel. And it's just sitting there, right? Steel block is just sitting there. What else is given? SG, specific gravity of mercury, is 13.56. And it's telling us, oh, and SG of steel is also given in the problem, which is 7.85. And we need to find the ratio of A and B. We're not going to find the exact value for A and B. We're just going to find the ratio of A and B. Okay, am I missing something? Yeah, this is open to the atmosphere. Am I missing something? No, looks good. So it's asked us to find the ratio between A and B. How would you guys approach this problem?
I was thinking that since the steel is submerged in both the water and the mercury, there'd be an equal and opposite buoyant force of the water onto the steel, and that would be equivalent to the buoyant force of the mercury onto the steel.
Not quite. Remember, because they both have different what do you call it? Specific weight, right? Specific weight of mercury is different than water.
Right, but wouldn't the ratio of A and B come into play there when you do include
the buoyant force is always pushing up on the object, never pushing down. Right? So if you have let's take this block right here. And what's the pressure distribution from water? It looks something like this. It's a rectangular pressure distribution. Right? And from the bottom of the block, you have a greater pressure from the bottom. So it's something like this. It's also rectangular, but it's much greater because once you go deeper in the fluid, you'll have more pressure. Right? And if you want to look at the sides should be a triangle, right? Like this, but they will cancel each other because they're exactly the same. So we don't care about the sides. They will cancel because it's exactly the same. It's like pushing on the block like this. But from the top and bottom, no, the bottom will have more pressure than the top. So here's where the buoyant force comes from. So you have a resultant force called buoyant force. So it's always pushing up on the object. Right? So you have how many buoyant forces you have? If this is the case,
one.
We have 2 buoyant forces.
2?
Yes. Because we have mercury and water, and they're both trying to lift this object up. I know water is trying to push down. That's the hydrostatic force, right? But I mean, there is the resultant force, which is the buoyant force.
Which will be like both of them combined though, right?
Both, yes.
Which is 1 though, right? Which is 1 FB though. Yeah, that's right. Okay.
So this FB is the resultant of this triangle, the pressure distribution, and this one. Why is FB from the bottom going to the top? Because the bottom has a greater pressure distribution. That's why it's going up.
Okay.
Good?
Yeah.
Are you guys following, or did I lose? You can ask, straight ask me. Is it confusing?
I think I got it. But
Okay.
there is two buoyant forces, right?
Yes, there is two
Okay.
buoyant forces because you have two different fluids. That's why. Yeah, that's why we have two buoyant forces. Okay. So how would you approach this problem? Any idea? What's the number one you should do when you see a buoyant force problem? First thing,
Free body diagram.
free
Or
body diagram, exactly. Yes, so you have a block, you have buoyant force from water, and you have buoyant force. They're not equal in magnitude because specific weight is different. So FB of mercury, and you have basically what?
The weight of the steel block.
Yes, exactly.
So when you include the buoyant force of water, does that already include the pressure at the top surface, right?
Yes,
Okay.
exactly. Because buoyant
Okay.
force is the resultant force,
Okay.
right? I think some problems, I think I saw some problems, but I mean, if you're trying to solve a problem and you have a buoyant force on the object, no reason to include hydrostatic forces and hydrostatic pressure. That's it. Buoyant force is the resultant force. Right? Some problems will deal with that actually. If you have like this one, a rod inside the water at an angle, some problems they're dealing with the rod and a string at the bottom. So if you include a buoyant force, no reason to include any hydrostatic forces because buoyant force is the resultant force. Okay, good now. Following.
Yes.
Okay, great. So let's solve this problem. How would you? It's I think the problem tells you it's in equilibrium. So summation of forces in y direction should be equal to what?
Zero.
Should be equal to 0. So if you expand this, how would you write the equation?
The two buoyant forces
The two buoyant
minus the weight.
forces minus the weight.
Mm-hmm.
Minus weight. Okay, and what's the definition of a buoyant force, or what's the equation for buoyant force?
Gamma times the volume.
Gamma times gamma of what though? Make sure you label all this stuff.
Well,
The liquid. That's
Gamma
in.
of the
The
liquid
water.
times the volume of what? Of the water or the liquid?
Of the object that's in the water. The part of the object.
The part, exactly, yes. Good, very good. Yes, it is actually the part in the submerged in the water. So B right here, it's not in water, it's in mercury. We don't include that in the formula for water, for the buoyant force of water. So this is a volume of object submerged in water, or submerged in that specific liquid we're trying to analyze. Okay, so let's write the equation here. FBW plus FBHG minus the weight. What is FBW in this case, following this formula?
Would it just be gamma water times the volume. That's. Oh wait, what was the width? Did it give that to us?
Is it necessary? It's not given in the
I guess
problem.
not.
Well, let's see. It's not given in the problem, so let's call width W and length, right? You have width, height, and length into the board.
Yeah.
So you have what? How would you calculate the volume?
It's the LWA.
Exactly, yes, LWA. And that's it for the buoyant force W. What about Mercury?
Sorry, I muted myself. It should be alpha or gamma HG LWB.
LWB, exactly, yes. You guys see the difference? Why we used B for this one and A for that one? Can someone explain why we used A for water and B for mercury?
Because that's the distance that they're actually submerged in the fluid.
Yes, height A is submerged in water, height B is submerged in mercury. Right, so part A is only included for water and B is only included for mercury. And you can switch them or flip them, or no, you can't do that. Okay, minus the weight. How would you find weight? What's the definition of weight?
Volume times specific gravity.
Volume times specific gravity. Yes, yep. It is actually volume times specific gravity. Oh, not gamma. I was going for weight is equal to mass times gravity, right? So, and how would you find mass given specific gravity?
You'd multiply it by the specific gravity and then divide it by G.
Yes, which is basically specific gravity times density.
Mm-hmm.
Once you multiply specific gravity times density times gravity, you'll end up with this. Are you guys okay with that, or should I try to re-explain it? Okay. Hopefully you guys are good with that. But yes, weight. I like to start from the top because sometimes I forget, oh, weight is equal to specific gravity times specific weight. So sometimes I would like to start from the top, right? Weight is equal to mass times gravity. How would I find mass? You can find mass from density, multiply it with specific gravity, you'll end up with the mass. Okay, and that's time volume, right? You need to get rid of, yeah, once you find density, hold on, once you find density, you multiply it times volume, you'll end up with mass. So far, so good.
So in problems that are like this, when it doesn't give us like a length or a width, we'll just put arbitrarily in like an L and a W.
Yeah.
To our formulas.
So for right now, you can use L and W.
Okay.
Right? Yeah, just use L and W because
yeah.
it's not given in the problem. And let's see what happens. Let's see what happens to this L and W.
They're just gonna go away.
Yes, they're gonna cancel eventually at the end. So we call this problem independent of the length and width. It doesn't matter if you have a 100-meter block, if you have a 50-meter block, same answer.
Does that only apply to like a rectangular object?
I'm trying to think about it. I would say maybe, yeah. I think so, yeah, maybe. Just a rectangular object.
That makes sense. Like where the dimensions would be matching. It would just cancel out.
Yeah, so the dimensions for this one, what's the definition of specific weight? Or how would you find this? How would we find this? What is SG and what is gamma in this case? Because I think we're missing a term, right? Are the units matching? What's the unit for weight? It's newtons. It's a force, right? If you multiply SG times specific weight, what's the unit for SG?
All newtons over meter cubed.
Meters cubed.
The units for SG, not for specific weight.
Oh, the
Oh, for
units for
SG, there's no
SG.
units.
It's
Yeah,
You
unitless.
can
there's
multiply by the
Yeah.
volume of steel.
It's unitless, basically, SG. SG is a
The
ratio,
factor.
it's unitless. So you have to multiply, so the specific weight is newtons per meter cubed. How would you end up with Newton alone? You would have to multiply times volume. So this is SG times specific weight times volume is equal to 0. That's how I like to solve these problems. Follow units. Because right now you can tell, I don't know the formula for W, right? I just start from mass times gravity and work my way to this one. Because I'm
And that
following
gamma,
units.
that gamma, is it water or mercury?
Good
Would it be
question.
water?
That's
Would it be
a
water,
good
right?
question. Is it water or mercury?
Water.
Okay, so Carlos is saying water.
It's
What do you
for the
guys think?
steel.
It's
Oh,
for
I
the
don't know.
steel, exactly.
Oh, for steel.
We're finding the weight of the steel.
Hmm.
So this is gamma of steel. And what about this volume?
Steel.
Is it the entire volume?
Yes.
Yes, because it's the entire volume of this steel block. That's why I like to start from the top. Weight is equal to mass times gravity, and then work my way to SG times gamma times volume. Because you can tell I don't have the formula memorized, really. Okay, great. So I think we have everything. If we can label stuff. So gamma of water is known, right? It's a constant value. And the gamma of Hg, what is it? Is it given?
It's just 13.56 times water.
Yes. This one is basically 13.56, which is this one, the specific gravity of Mercury, times what?
Gamma water.
Gamma water. You'll end up with gamma mercury. And how would you find this? What's SG for steel? It's
7.85.
7.85. What is gamma for steel?
Gamma for steel. It'd just be that times water. Times
So
gamma water, right?
it'll be which one? Gamma of steel?
It'd just be 7.85 times gamma water. Or
Oh, well, SG times gamma of steel is what, basically? It's gamma. It's gamma
That's
of water.
gamma's.
No. Yeah, I think we confused ourselves with this
Because
SG times gamma of.
yeah, because it should have just been gamma
Yeah.
of steel, and then we would have converted to SG gamma water, right?
Yes.
Yeah, that's what I meant last time.
Yes, yeah. So let's not confuse ourselves and work from mass times gravity is equal to 0. Well, gravity is a constant value. We can assume it's 9.81. And what is mass? How would you find mass?
just density times volume.
It's basic, yes. It's density of steel times volume of steel, right? What's the definition of density? It's mass over volume. So if you multiply mass over volume times volume, you'll end up with mass alone. So how would you find density of steel?
Take the SG, multiply that by gamma water. to
Of
get,
gamma of water or density of water?
Yeah. Oh yeah,
Density.
you're right. Density of water.
Density of water. So that's the definition of mass. It's Sg times density of water times volume of steel. See, yeah, try to not memorize this stuff because you can easily confuse yourself. Start from mg, start from mass times gravity, and work your way. Because remember, Sg, if I scroll here, Sg is equal to density of the object or density of the fluid over density of water. Or you can write Sg is equal to the specific weight of the object or fluid over specific weight of water. They both mean the same thing. Why can we do that? Because we can multiply this times gravity, and density times gravity, you'll end up with specific weight. Good?
Sounds
Okay.
good.
Okay, great. Great. So you see how you can easily get confused with the units and stuff. That's why I always double check units, really. I mean, once you're trying, like once you finish your quiz or exam, if you have like 3 minutes or 5 minutes, just go over the problem and check units. Because I can tell, like when I took this class and when you take heat transfer and thermal system design and stuff like that, you'll see how if your units don't match, you'll end up, yes, of course you'll end up with a value, but that value is wrong. So it's you can easily get lost here. So always check units. If you have 5 minutes, go over the problem and check units. Okay, great. So how would you solve this? Let's see. Gamma, we said gamma of water times LWA plus gamma of mercury LWB minus Sg of steel times density of water, and then volume of steel. What should I write for volume of steel? This term.
LW times A plus B.
LW, yes, exactly. It is actually A plus B because it's the entire volume of the block. That's how you find weight. And what are we forgetting? We're forgetting one term, right? Which is
Gravity.
gravity. Yes. Good. I think we know everything in the problem now. So I think, who asked about L and W? If we should have L and W in the problem?
Oh, that was me.
Yeah, that's you, Nick. Okay, so you see how you can factor out L and W?
Yeah.
Because this term has L and W, this one, and that one. And what's a common term between these? L and W, yes, it's a common term. And what about, there's another one. We
It'd
can
just be gamma water.
Gamma water. How would you factor out gamma water from here?
Well, I mean, it'd take more work, but
Yeah, you
I mean,
can, right?
yeah.
You can say it's specific gravity times, right? But I mean, no, there is one term that you can factor out easily.
G
Row water?
or no?
It's gravity.
It is gravity. Yes, raw
Yeah,
water
right
is
there.
a good answer. You can factor out raw water, but I mean, gravity is right there. Once you factor out gravity and LW, how would your formula look like? Can someone try to tell me? So we factor out the gravity. Is it writing? Yeah. And WL. So how would you write this formula?
Density of water times A
Density of water times A
plus
plus
density of mercury
density of mercury
times
times B minus
SG steel density
SG
of water
steel density of water
times A plus B.
times A plus B, exactly. And that's equal to 0. And here's your simplified, or let's say oversimplified, because you don't have to really simplify that formula. You can just plug in values and get the answer. And you can, if this is equal to 0, that means this term will cancel. Right? So we don't need what? Length and width. We don't need these two. They're in the problem is independent of length and width.
You couldn't just see that though, right? You have to like put it and then you still cancel out.
Yeah, you can. You don't have to go. I'm just going to this formula right here just to have you guys practice like gamma and SG. What's the difference between the two? Density. Like I'm just trying to show you how we can manipulate all these three for later chapters. But you don't have to go like through this entire process. You don't have to.
Oh, okay.
Just showing you, because right now, once we get to chapter 5, when I say gamma, oh, you know exactly, oh, it's weight over volume. Like from the top of your head, you don't have to go look in tables and stuff. You know it's weight over volume.
No, I mean like as far as like when you have a block, is it always the case for blocks to merge in like liquid in a liquid to for the like the width and I mean the length is the width to cancel out and not the height, just based on the height, right?
Yeah, the height you can't cancel it because remember pressure depends on it. But yes, length and width, they're horizontal on a horizontal plane and they basically have the same pressure. So probably yes, you're right. You can cancel them. But height is different because pressure depends on height. And then you can solve this problem. Remember, this problem is asking us about the ratio of A and B. So you need to find this ratio. A and B is what? Once you solve the problem, you're not going to find a specific value for A and B. You're only finding the ratio between A and B. And you can plug in all the values and you can solve the problem.
Cool.
Good. Sounds okay.
Yes.
Okay, great. Did I confuse you guys, or hopefully everyone is following? I didn't confuse anyone.
Just besides that, weight equals mg, and we were trying to simplify it without writing it down. But besides that,
Okay. Okay, great. Because remember, yeah, that's how I like to solve any buoyant force problems. I remember weight is equal to mg. G is constant. Don't worry about it. And m is basically rho times volume. So if you can find rho, you can solve for m. And the way we find rho is, remember, Sg is equal to rho of the object or fluid over rho of water. That's how you, and the problem will tell you Sg. What is Sg? Of course, that's Sg is going to be given. Okay. Any questions before we end the meeting? Any more questions for tomorrow? Are you good? Do you guys feel prepared for the quiz?
More or less. Are
Okay.
you posting? Where are you posting these videos? Because you're recording them, right?
Yeah, I'm recording them. I'm posting them, or I'm submitting them to the engineering or the MEP office, but I'm not posting them anywhere where students can access them. But I'm hoping, like, I have them on my computer. So I'm hoping to set up a Discord server. I know I always say that, but hopefully if you can post your Discord name and chat and I can add you, and hopefully we can make a server where I can post all these videos and you can just click on them and watch what problem we're solving and try to do it yourself. Right, so if you can, in chat, if you can post your Discord tag number, is that what they call it?
So are they just keeping them as like a check for you, or I'm confused?
Yeah.
What?
Yeah.
Oh, okay.
That's,
I figured
think
they'd
so.
like do something with it, but all right.
Hopefully they can share them in an email or something, but for now let's set up a Discord server since we have access to it. And if you can, I don't know how to add people still, so let me give you my information and you can add me and just send me a message saying hey with your name, and hopefully I can set up a server tonight. So it is this one. That's my name on Discord. Good. If you can, yeah, if you can just message me and hopefully we'll set up a server. And if you're doing a homework problem and you're confused, if you can't reach the professor, of course, always reach the professor first. But sometimes, yeah, if you're doing a homework problem, it's in the middle of the night, right? And you need some help, why not? Just post it in there and maybe I'll help or some other student will help. Okay, so right now I have Nick and Carlos and Tenzin. That's what I have on my Discord. And Chris, oh, can you message me to Chris? Because I don't know how to add people. And who else are we missing? David, do you want to be on the Discord server?
Yeah, I'm working on that right now.
Okay.
I just sent you a friend request.
You just sent me a friend request. Okay, let me check. Oh, yeah. Okay. And that's Gene, right?
Yeah, that's right.
Great. Okay, so I have most of you guys. I'm just waiting for David, right? You said you were working on it? Oh,
Yeah, I just sent it.
I think I received it.
Yeah, perfect.
Perfect. And who else? Chris, you want to be in the Discord server? That's fine. It's completely optional. You don't have to be, really.
Sorry, I was muted. Yeah, I'm trying to send you a request right now.
Okay, great. This is completely optional, guys. Maybe we can help each other, right? With this online thing going on. I mean, is it hard learning fluid mechanics for the first time online? I mean, I would assume it's hard, right? Okay, and that's you, Chris, right?
Yeah, I just sent mine.
Okay, great. So I have all of you then. And we can set up a Discord server hopefully tonight. Okay.
Thank you, Sama.
All right, no problem. Thanks for coming, guys.
Yeah,
Appreciate it.
thanks a lot.
No problem.
Yeah.
Have a good day, man.
All right, take care, guys.
Thank you.